Hello, my lovely calculus kids. This is Sean from Alexander Tutoring, and today's lesson is on implicit differentiation. This confused the heck out of me when I saw it the first time. Um, you'll see what we have here. And the thing that's confusing about, we're supposed to take the derivative of this thing in parentheses, and immediately the thing that confused me the most is like, why are there y's everywhere? Usually you have something like y equals something with a bunch of x's in it, right? Now we got y's just kind of showing up everywhere. How do you take the derivative of that? And the realization or the trick to implicit differentiation is to realize that it's really the chain rule in disguise. So if you haven't seen my video on the chain rule, that's the last one I sent out. That's super important. But recall that the chain rule is the way I like to talk about it in words. The chain rule is the derivative of the outside function with the inside function plugged in times the derivative of the inside function. So recall that inside and outside, the chain rule is for composite functions, or when you have one function plugged into another. Okay, so I'm going to just do a quick recap of the chain rule. I'm going to do a simple chain rule problem like if you have something like the sine of 2x, and we want to take the derivative of this, well, we're going to think of this as a composite function, one function plugged into another. So the outside function is the function that has something getting plugged into it, and the inside function is the thing getting plugged in. So in this case, we can think of this as the inside function being 2x, which is being plugged into the outside function sine. Does that make sense? If you plug 2x into sine, then we get sine of 2x. So let's read through these words. To take the derivative of this, we would take the derivative of the outside function. The outside function is sine, so the derivative of sine is cosine. Good job. The next sentence, with the inside function plugged in, meaning we leave the inside function plugged in to whatever we just took the derivative of, times the derivative of the inside function. Well, the derivative of 2x is, so we go times 2. So there's a little chain rule recap. Now, taking that back up to implicit differentiation, remember I said it's the chain rule in disguise? Well, the way we're going to think of this is the y's, the confusing y's up here, they are some function of x that we just don't know what it is, right? So it's going to be like y equals blah, 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 things with x's in it. We just don't know what it is yet. But we're still going to treat it like it's some function. We just don't know what it is. So let's go through this. So we're going to take the derivative of both sides of this equation. So the first thing is derivative with respect to x of x squared. That's easy. Hopefully you know the power rule by now. That's simply 2x. Okay, here comes the first weird one. Now we have x times y. So that's one function times another. So we're going to use the product rule. I'm assuming you know the product rule. So the product rule says you take the derivative of the first function. So the derivative of x with respect to x is simply 1 times the second function as is. So we'll just leave it alone. Plus the first function, in this case x, just left alone, times the derivative of the second function. Now, we don't know what the function y is, so we're just going to call the derivative of the function y prime. That's what prime is, just another way of saying derivative. Okay, we don't know what that is, so we're just going to call it y prime. Why not, right? Okay, so that's that part, plus. Now here's the tricky part, y cubed. Now, again, y is some function we don't know. We're going to treat it like the inside function using the chain rule. So let's just do this. What does the chain rule say? We take the derivative of the outside function. The outside function is something cubed, right? So the derivative of the outside function, we use the power rule. The 3 comes down. We leave the inside function plugged in. In this case, like I said, the inside function is y. And then the power rule says we subtract 1 there. Times the derivative of the inside function. And again, we're calling y the inside function. we don't know what the derivative of it is, so we're just going to call it y prime. That's the derivative of the inside function. Derivative of 0 is 0. And then we have this. Now, through cleverness, what we can do is solve for y prime, or the derivative of y, to get our solution. So you'll notice we have two terms with y prime in it. So I'm going to move the two guys that don't have y prime in it to the other 1 times y is y side of the equation, right? And move my equal sign to the middle here. So we're left with x y prime plus 3y squared y prime here. And then we have minus 2x minus y on the right. Now we have two terms with a y prime in it. So how do we get to it? We factor it out. Okay, and then we can simply divide both sides by x plus 3y squared to get to the y prime. Boom. And guess what? We just solved for the derivative of y. Y could be any function. Check it out. So again, the key to understanding implicit differentiation is realizing that it's really the chain rule in disguise. All right, team, I hope that helps. Have a great one.